will be Raresh Bayan and the team, and is about Yoop platform.
Okay.
Okay, so I'm Katalin Juga, and together with Raresh, Norbi, Gabi, Podo, and Madalina, we build a Yoop platform. Yoop platform is a cloud platform designed for hosting server function serverless mode, with the goals of focusing on simplicity, offering a pay-as-you-go method of hosting, and enabling functions to auto-scale, while also providing statistics and analytics and a bit of machine learning predictions in terms of cost and usages for these functions.
A little background on what a serverless function even is. First, it is a concept that started with cloud computing, and it is meant as an alternative to servers, like, because as the image suggests, there are still servers that run your code, but you are not managing them yourself. And the biggest benefits are automatic scaling, because there is not just one machine that runs your code, but it is on demand. And this scaling happens based on events, like how many users request your code, like your API, for example. It is much more cost efficient because you don't need one server to run all the time. You can have just a very small machine that runs when you don't have any traffic, and this only scales up when there are a lot of users. You don't have to manage the servers yourself, you just put your code there, and the platform, for example, our platform, manages automatically the machines that run your code, and it's very easy to deploy. Again, you just paste your code or upload it in some sort of file, like a Docker file. Compared to traditional servers, like a virtual machine, for those you need someone, either yourself or to hire someone else that manages the machine itself, and you need to download all the services that run your code. Here, everything is bootstrapped for you. You don't need to worry about that. Instead of having a set number of CPU cores and memory allocated to you, you have dynamic scaling, again based on what you need. You don't just pay a fixed amount per month or a fixed cost up front, but you only pay for what you use. Instead of having the machine always running, it only runs when you need it. And again, the deployment is very simple. You don't need to worry about anything else regarding the OS or anything else running on the machine. And as other competitors that we took inspiration from and alternative, the main three providers are Amazon through AWS Lambda, Google through Google Cloud Platform, and Azure, Microsoft's option with Azure Functions, and also ServiceNow, which is more geared towards visual programming and not DevOps or programming in a traditional way.
So here we have an architecture diagram. As you might expect, there's a lot of services that need to talk to each other, but it's not that complicated. Basically, we have like two clients, one for the landing page and authentication flow, and a dashboard where the users can administer their own functions. Each request towards the other services of the platform go through an authentication and authorization server proxy that basically authorizes the request. This is the main proxy on the platform. And we also have a few extra services that manage expenses, payments, and predictions. Next, we have the function manager that basically will store the function data in a separate database that we could replicate and basically scale up or down depending on how many functions we need. Next, inside the Kubernetes cluster, there will be our main, sort to say, development environment for our functions. Is the function bootstrapper that basically will take the code and bootstrap it in deployments and services, so it can be then shared through the ingress load balancer towards the clients. And inside the same Kubernetes cluster, we have a Prometheus service that will basically serve analytics for the usage of the functions. And with this analytics, we have a machine learning and data pipeline that will serve for predicting the usage and estimates in terms of costs for users. And the monitor will basically look at this analytics as well and decide if we need to scale up or down these functions in terms of usage.
So for the machine learning and data pipeline, we used Prefect, which is a data orchestration tool found in Python. And once we have our Kubernetes clusters running, we fetch set data from the pods using node metrics and kubestats. We set up Prometheus to do a scraping job. And after that, we fetch it with Prefect. And we process the data because we have data in forms of node labels. That data needs to be pre-processed, and we train a XGB model, a boosting gradient, my bad, for predicting CPU usage. And we also have other analytic and stats. And this data gets passed to our function monitor. Okay. Also,
in terms of technologies, we have quite a few stack. This is just the main ones. Mainly for front end, we are using Astro and Vue.js. For our machine learning in data analytics, we are using Python. Deno is basically our hosting environment for the functions. We decided to just run with TypeScript code for this for the time being. Maybe we'll decide on other runtimes as well. Docker and Kubernetes are basically the hosting environment for the functions. This will allow us to scale up or down the services. Nest.js and Golang and .NET Core are mainly used on the back end, either for interacting with the Kubernetes and Docker API or for the proxies and other related services. And for the databases, we are using Cassandra and PostgreSQL. And now we have a demo from our colleague Gabriel that he kindly recorded for us, as it's quite a heavy, intensive workload to just host yourself. This is a bit of the landing page. And this is basically the main interface through which the users will input the functions. On the left side is a code editor that will basically allow users to put their own code in, and this will be then served kind of like an HTTP server, and the request will get a response back with the code the user processed. It's just basically a wrapper of a fetch function that has a request object, and this request object will have different parameters like headers, body, or methods, through which the user can interact with different type of events. And on the left side, we have basically the output of the function. We have a predefined subdomain for these functions that will basically make the function accessible to the general public. And we have a save and deploy button that will automatically save the code from the editor and deploy it in the runtime. And now Gabi just basically modified the code. We'll save it and then reload the page to see that the changes have happened. And yeah, he basically just did that for like a minute and a half, and he had some fun, I guess. Moving on.
So the next steps in our roadmap will be to build a dashboard for our application, to integrate the services used for function usage analytics and cost predictions, to have different language support for functions, like SDK for popular programming languages like Golang, Python, so on, and function building using code blocks, providing language agnostic and dynamic means for building functions. So the job's still not done. And basically that's it.
Thank you. You have any kind of questions?
Just one question. What kind of data you have in Prometheus?
Well, basically we have CPU, for how much time the pod was running, and other kind of stuff for that pod. So pod-related metrics.
Okay, okay, thanks.
Thank you. We will continue with the next presentation from the live Connect.